Hi guys, please make sure that you either have a paper copy of Day 3 notes or that you have downloaded Day 3 notes from Schoology. Remember, you can always pause this at any point if I'm going too fast or something happens, you need to pause it, no big deal. Okay, so Day 3 is 4.2 compound interest. Before I get started, make sure you have a calculator of some sorts. Graphing, scientific, either will do. I'm going to talk through mostly using the graphing. There's not a ton of it, but for calculating, you'll need a calculator. Okay, so simple interest formula. We've talked about this before. You've probably learned it in business before. Is that interest I equals P times R times T, where P is your principal, what you put in, rate is your percentage rate, and T is time in years. So that's simple. It's only being calculated once. Compound interest is more, well, it is what our banks do. So it's giving you interest on first your money, then the next month, next year, whatever. It's giving you interest on your money and that interest that you already have earned from previous months, years, whatever. So this is a way more realistic equation, and like I said, how your bank accounts are figured out. A equals P times the quantity of 1 plus R over N, all raised to the N times T. This is a formula that you need to have memorized, so keep that in mind. You're going to be working with it a lot this chapter, but you do need to have that down. It will not be provided for you. And below here, I just have what everything means. A is your future value, what you're looking to earn, or what you will earn. P is your present value. It's your principal. I like to think about it as what you put in. Rate for R. T is time, but be very careful. It is time in years. Therefore, if they say something like it's in there for 6 months, you would not put 6 because that would represent 6 years. You would put in 1/2 since 6 months is a half of a year. And N is the number of times compounded per year. And what I mean by that is if they say that it's compounded monthly, that's happening every month, so it's 12 times a year. Semi-annually, if you think about a semi-annual sale, that's happening twice per year, so N equals 2. Semi-annually and monthly will most likely be, or those are the most common ones that you'll see. Yearly, annual, so they'd say annually, that kind of thing. Okay, so first one, find the future value and interest, we'll talk about interest at the end, earned if $1,100 is invested at 6% interest compounded, and we have two different situations, A, semi-annually for 5 years. Okay, so I like to just write my formula. The more I write it, the more I know it. A equals P times the quantity of 1 plus R over N raised to the NT. And let's fill in what we know. We know that we're looking for a future value, so A is going to stay as is. A equals, well, our present value, if we're putting in 1,100 times the quantity of 1 plus, now we don't put our rate as 6, it's that 6 divided by 100, so 0.06. And semi-annually means we are compounding it twice. Raised to the NT, so 2 times the 5 years they have allotted. Now, you could go and simplify that 1 plus 0.06 divided by 2, but in reality, this is set to put in your calculator. Just be very careful with your parentheses. Put in your 1,100, parentheses, 1 plus 0.06 divided by 2, parentheses, caret key, and I always just go and say to the 10th rather than the 2 times 5. So calculator. And we round to the nearest cent. Therefore, A equals $1,478.31. Never, ever, ever round until you are at the very end. Otherwise, you are going to have an answer that is a little bit off. That's called intermediate rounding, and we do not do that. You only round at the end. Now, we answered the future value, but we do have to figure out the interest. Interest is quite easy. I've put in $1,100, and I'm walking away 5 years later with $1,478.31. Everything past that $1,100 is interest. It's what the bank has given me for holding on to my money. So our interest will be that $1,478.31 minus what we actually put in. Therefore, we are stepping out 5 years later with $378.31. Unfortunately, none of our bank accounts are giving us 6% interest these days. When I first started, I had an online bank account that was giving me 5%, and that very quickly went away and is now almost nothing. Okay, at this point, I kind of wish you guys, or would want you guys to try the next one on your own, so feel free to pause it. I'm obviously going to just keep going, so pause it if you guys want to try it on your own, which I do recommend. Okay, monthly for 5 years. A equals that P times the quantity 1 plus R over N raised to the NT. Same problem, just working with monthly instead of semi-annually. A equals that 1,100 times the quantity of 1 plus 0.06 divided by 12. Since we're doing this monthly, this is more how your bank account is figured out. Then to the 12 times 5 years. Once again, at this point, I'm ready to plug it in my calculator. Just be very careful. And we should end up with A equaling $1,483.74. So even though it's being compounded a lot more than the last one, it's not making you that much more money. More, but not that much more. And interest, once again, I'm going to take that value that I'm walking away with, subtract what I put into it, which is the 1,100, and I have made $383.74. Okay, last one on this page. A little trickier. Find the present value of $6,000 invested for 10 years if the interest is at 4.75% compounded semi-annually. So key thing here is we're looking for our present value, how much we actually need to put in so that after those 10 years we walk away with $6,000. Once again, I'm just going to write my formula. Sorry, my pen's not working. Okay. So we're walking away with $6,000. We've got a rate of 0.0475. And we are compounding this semi-annually, so 2 raised to the 2 times 10. Now, it's your choice. You can either do it all at once in the calculator or not. You can either, you might want to clean up this 1 plus 0.0475 divided by 2. It's up to you. Just do not round until the end. You keep everything exact and use your calculator and all that in order to avoid rounding till the end. You're always welcome to get an answer, and then if you hit just second answer, which is second, the blue button at the top left, and then the negative key next to the decimal, that gets you your answer from previously. So you can always do that second answer to get what you had from above. I'm just going to go ahead and, while we're at it, divide right away. Since I want this p, I'm going to divide by everything that's connected through multiplication to that p. So I'm going to divide by 1 plus 0.0475 divided by 2, and I might as well call that to the 20th, and divide that by both sides. Once again, do not round until you get your answer. You will know you've done it correctly if you end up with a p equal to $3,752.09. Please, please, please pause if you are not getting this. Help your neighbors out. See if they've gotten the same answer as me, and help them out if they're not. So I'm just going to write a note. Don't round until end. Okay. On this side, starting with 3, I think 3 is the trickiest of the worksheet. So if I were you, I'd be putting a star next to that one. Make sure I'm studying that, putting that on my objective sheet. At what rate should you deposit $5,000 to be compounded quarterly to have $7,250 at the end of 5 years? Round your answer to the nearest tenth. Okay. Writing our formula like normal. Let's fill in what we got and go from there. At what rate? So we're looking for R. And we want to make $7,250 from the $5,000 that we put in. And that's that 5,000 times 1 plus our R. And we're compounding quarterly, so divided by 4. Raised it to the 4 times 5. So just simplifying this a little bit. Well, it's pretty much simplified, other than that's to the 20. I need to get that 1 plus R over 4 to the 20th by itself. And it's connected to that 5,000 through multiplication. So I'm going to go ahead and divide by 5,000. And remember, we are not allowed to round intermediately. We cannot round until the end. So at this point, you can either, if it is an exact decimal, you put the decimal, or if it comes out repeating, change it to a fraction. But I know that 725 over 500 reduces to 1.45. Now, to get inside that parentheses, we need to get rid of that 20th power. And the inverse operation of the 20th power is to take the 20th root. Now, you've got some options in how you do this. You could go and take that 1.45, put it in parentheses, use the caret key, and do 1/20th. Instead, what I want you to try is actually doing the 20th root of 1.45. So now in your graphing calculator, or with your graphing calculator, I want you to do 20, hit your math key, and then straight down from there I want you to go to number 5, which is an x root, and hit 5. Now, especially if you have the newer operating system, it should look like you're taking the 20th root of something. If you have the older operating system, it will say 20x root, which is representing that 20th root. Okay, so the 20th root of, and then put your 1.45 in there, equals the 20th root of the 1 plus 4, or r over 4, all to the 20th. Now the only thing we've forgotten is that, hey, we took an even root, so really we need that plus or minus in front of that. I fear I'm going to run out of room. So now I have plus or minus the 20th root of 1.45 equals 1 plus r over 4. Almost there. Now I'm going to go ahead and subtract 1. So I'll have plus or minus the 20th root of 1.45 minus 1 equals r over 4. And then finally, to get r by itself, I'm going to multiply both sides by the 4. And I will have 4 times the quantity of plus or minus the 20th root of 1.45 minus 1. That minus 1 is not under the root. Now, when you think about this, the 20th root of 1.45, when it's positive, will be positive. When it's a negative 20th root of 1.45, it will be negative. A negative minus 1, you're not going to have a negative rate for something that is growing. Therefore, we can just disregard that minus. And now in our calculators, be very careful. 4, parentheses, 20, go to math, go down to that x root, so 5, and then put your 1.45. Make sure that it stops the radical at that point, and then subtract 1, close your parentheses. Please pause it and help your neighbors if they're struggling with it. Your answer should be 0.075007334. Let me talk through that again. In your calculator, 4, parentheses, 20, hit math, go down to the x root, which is 5, put in your 1.45, make sure that's it for the radical, subtract 1, and then close your parentheses. And at this point, we now should have r, r equals approximately, 0.075 and so forth. But that's not actually our percent, so move that decimal 2 places to the right, and we end up with a rate that's approximately 7.5%. Like I said, I think that's the toughest one, so make sure that you study that. Feel free to play that over, go back to it if need be. Okay, last idea is there a limit to interest? Okay, what do you think? Yes or no? Okay. If I compound it, quarterly, and then I go monthly, daily, hourly, every minute, every second, is there going to be a limit, or am I going to just become this massive millionaire right away based on how often I am compounding? Well, I don't know. Let's see. To do this, we're going to invest $1 at 1% for 1 year, just to make things easy. Because when we do that, think about our formula. This turns into A equals 1 times 1 plus, 100% is 1. If I'm only compounding, we don't know, so I'm going to do n. And then we're doing it for 1 year, it's going to be to the end. So we're working with that formula really of 1 plus 1 over n to the n. So in my table here I have n, and then I've got that 1 plus 1 over n to the nth. And let's just go ahead and put in some values. I'm going to put in 1, I'm going to put in 5, I'm going to put in 10, I'm going to jump to I don't know, 1,000. Jump to, well, just go 10,000. And then go 1,000,000. So this means I am compounding it 1,000,000 times per year. Well, let's start with the 1. Feel free to use your calculator. This one we don't need it for. We're just replacing n with 1. So 1 plus 1 to the first is 2. From here on out, I am going to use my calculator. 1 plus 1 over 5, all to the 5th, is 2.48832. Well, it's some nice growth from 2 to 2.48. I'm going to try that 10. 1 plus 1 divided by 10 to the 10th. 2.5937 dot dot dot. 1 plus 1 over 1,000 to the 1,000th. And we're up to 2.7169 dot dot dot. Okay, I see lots of growth. Okay, 1 plus 1 over 10,000 to the 10,000th. Darn. 2.718145. Not that much growth from 1,000 to 10,000. I'm really hoping for more as we get to that 1,000,000. 1 plus 1 over 1,000,000 to the 1,000,000th. Gives you 2.71828. Giving you a little bit of time to think. But I could keep going, and unfortunately, it is not going to grow limitlessly. It is going to eventually approach a fixed number of E. So even that 1,000,000 was awfully close to this number E. E is not a variable now. E is a number, much like pi. E is approximately 2.71828128, and goes on. It is irrational. And this is really often referred to as Euler's number. I know it looks like Euler, but it's pronounced Euler, Euler's number. So unfortunately, there is a limit. And with that being said, we come up with the compounded continuously formula. So constantly compounding, which is an easier formula, in my opinion, to remember. A equals P, so what you put in, times E raised to the RT. Both R and T are in the exponents. So P is still what you put in, your present value. E is that number. It is a number. R is rate and T is time. Now in your calculator, there's a few places to find E. You can hit the second key and then go straight down and look for right above the key that says ln. There should be a blue e to the x. So you're welcome to hit that second ln, and it instantly puts e raised to something. Well, if you don't want it always being raised to something, you can also hit second divide. Second divide gives you e on your screen right away. So take a minute, look for that. Feel free to pause. Help your neighbors out if they don't see it. Once again, either second straight down to the ln or second divide. Okay, and we'll use this. Like I said, I feel like this one's a lot easier to work with. Find the future value of 4530 if invested for 7 years at a rate of 3.8% compounding continuously. Right away, I know I'm using that PERT formula, A equals P times E to the RT. So we're looking for future value. If we put in 4,530, E is E, times 0.038 to the set, or times 7. And then I'm going to plug it all in my calculator at once. 4530, either second ln or second divide, raised to that 0.038 times 7. If you have the newer operating system, it should show that that 0.038 times 7 is already in the exponent. If you have an older one that actually shows the caret key, make sure you do parentheses 0.038 times 7, or it will not calculate it correctly. Also, use common sense with these. You're not going to put money in, have it grow at, an interest rate of 3, 4, 5, and then actually end up with less money. You're also not going to take a few $1,000s and become an instant millionaire. So make sure your answers are feasible, that they make some sense before you call it a day with the problem. And when you do this, you should end up with A equaling $5,910.45. And that's that. Okay, so homework is day 3. Give it your best, and we'll go through it tomorrow. Good luck to those that are going to BPA tomorrow.